Welcome to the session. Today in this session, we discuss the numerical examples on DC generator. We know the general EMF equation of DC generator. So that is given by E equals Z pi P divided by 60 into P by A. So by using this EMF equation, we'll see the numerical examples. So first we'll see with a 4-pole 1500 rpm DC generator as a lap wound armature having 24 slots with 10 conductors per slot. If the flux per pole is 0.04 Weber, calculate the EMF generator in the armature. Next, what would be the generated EMF if the same winding is wave connected? So in this example, first we'll see the given values. He has given the number of poles 4 and the speed of the armature 1500 rpm and the winding is lap connected. So we know that when the winding is lap connected, then the number of parallel paths is always equals to number of poles, and flux is given, that is 0.04 Weber. So the equation for EMF is given by Z pi P divided by 60 into P by A. So he has asked to calculate the EMF generated. So as it is first, in the first question it is lap connected. So the EMF is given by Z pi P divided by 60 into P by A, where A equals to P. So on substituting the numericals, so we get EMF equals 240 volts. And next question, he has asked to calculate the EMF generated when it is wave connected. So during that, the number of parallel paths is always equals to 2. So as you seen in the wave connection, so the number of parallel paths must be equals to 2. So on substituting the again numerical values, that is number of conductors. So here the number of conductors is not given directly. So if you want to calculate the number of conductors, we have the formula, that is number of slots into number of conductor per slot. So in the example, he has given total number of slots is 24 slots and each slot will contain 10 conductors. So to calculate the total number of conductors, so Z is given by slots into conductor per slots. So the total number of slots is 24 and 10 conductor per slot. So the total number of conductors is 240. So on substituting the values, so we'll get 240 volt for lap connected, and the same when you go for an wave connected, here the number of parallel paths will change, that is A equals to 2. So during that, the EMF is given by 480 volts. So what we can observe, that only the change in the number of parallel paths. So the second one, a 4-pole generator with wave wound armature has 51 slots, each having 24 conductors. The flux per pole is 0.01 Weber. At what speed must the armature rotate to give an induced EMF of 220 volts? Next, what will be the voltage developed if the winding is lap and the armature rotates at the same speed? So the first question, he has asked to calculate the speed of an armature. Next, we have to calculate the voltage developed if the winding is lap connected for the same speed which we'll get in the first question. So we'll see with the given examples. So given values, the number of poles is 4 and it is wave connected, hence A equals to 2, and slots is given 51 slots and each slot will contain 24 conductors. Therefore, the total number of conductors equal 51 into 24, so that is 1224 conductors, and he has given the flux value 0.01 Weber and EMF is given 220 volts. So here we need to calculate, he has mentioned to calculate the speed. So we'll use the same EMF equation, that is E equals Z pi N divided by 60 into P by A. So as it is wave connected, A equals to the 2. So flux is given 0.01 and poles is given. So we need to calculate number of, that is speed. So on substituting the values, we get N equals 539.21 RPM. So next question, he has asked to calculate the EMF generated when it is lap wounded with the same speed. So we know that when it is lap connected, number of parallel paths is equal to the number of poles, so that is 4, and speed we have calculated, that is 539 rpm. So on substituting the values, so number of conductors will remain same and even the flux will remain same. Only thing, we have to substitute the A equals 4 as it is lap wounded. So the EMF what we are going to get is, that is 110 volts. So the example is same as previous one. So now we'll see the different types of shunt generator numerical examples. So we have basically 3 types: shunt generator, series generator, and third one is compound generator. So in that again we have seen that a long shunt and short shunt. So before going to the numerical examples, so we'll go with the uh, formulas for different types of shunt, that is series, and one more compound. So first one is the shunt generator. So in shunt generator, the armature current is always equals to, it is a sum of line current and the shunt current. So and shunt current is given by Vt divided by Rsh. So where V is the terminal voltage and Rsh is the shunt field resistance. So if you want to calculate EMF generated, so that is given by terminal voltage plus Ia into Ra plus voltage drop across the brush. So that is Vb. If you want to calculate the power developed across an armature, that is E into Ia, and the power delivered to the load, which is equals to Vt into IL. So and these two will remain same for other types also, that is series generator and even for the compound generators. And in series generator, we have seen that as the winding is connected in series, so the armature current also equal to the line current, load current, and also equal to the series current. And the EMF is given by Vt plus Ia into Ra. Even we have to consider the voltage drop across and series winding, that is plus Ia into Rc, and as it is Vb. And the Pa will remain same, E into Ia, and PL, that is Vt into IL. And next one is the compound long shunt generator. So here the field winding is connected in parallel with the both the armature and the series winding. So therefore Ia is given by combination of ISH plus IL, and ISH is equals to Vt by RSH. Whereas the total EMF is given by Vt plus Ia into Ra, the voltage drop across series winding Ia into Rc plus Vb, and whereas the Pa and Pl will remain same. So when you go for the short shunt generator, so here the Ia is as it is IL plus ISH, but here when I go for an ISH, so it is short shunt, means only the armature winding will be in parallel with the field winding. Therefore, the shunt current is given by EMF generated minus Ia into Ra, that is voltage drop across armature divided by RSH. So don't get confused. So ISH equals VT by RSH for long shunt generator. So whereas for short shunt, ISH equals E minus IA into RA divided by RSH. And in this one, the ISC is equals to IL. And total EMF is again VT plus IA into RA plus IL into RAC plus VB. And even you can write ISH in the form of terminal voltage. So that is given by VT plus IL into RAC divided by RSH. So by knowing the given value, if it is EMF is given, we can go with ISH is equal to E minus IA into RA divided by RSH. If the terminal voltage is known, we can calculate ISH equals VT plus IL into RAC divided by RSH. So by using these numerical, we'll see the numerical examples. The first one, so just is simple one. The EMF generated in the armature of shunt generator is 625 volts. So he has given the total EMF, that is E, when delivering its full load current, that is IL, of 400 amps to the external circuit. The field current is 6 amps and the armature resistance is 0.06 ohm. What is the terminal voltage? So as it is a shunt generator, we know that IA equals IL plus ISH. So he has given the IL value, that is 400 amps, and IS is given 6 amps. So therefore IA equals IL plus ISH, that is 406 amps. So he has asked to calculate the terminal voltage. So we know the formula E equals VT plus IA into RA plus VB, and he has not given the voltage drop across an brushes. So we will not consider that. So therefore, if you want to calculate VT, therefore VT equals E minus IA into RA. So on substituting the values, RA is also given, that is 0.06 ohm. You will get 600.64 volts. And next one, so here a 30 kilowatt 300 volt DC shunt generator has armature and field resistance of 0.05 ohm and 100 ohm respectively. So calculate the total power developed by the armature when it delivers full output power. So he has given the total output power, that is 30 kilowatt. So P out is given, and the terminal voltage also he has given, that is 300 volts. VT is given. So we need to calculate the total power developed by the armature, nothing but PA. So before going to that, first you calculate the IL value. So IL is given by P out divided by VT. So we are going to get 100 amps. So as it is a shunt generator, so we can calculate IA. IA is given by IL plus ISH. So here you got IL, that is from the output power and the terminal voltage. So next I need to calculate ISH value. So we know the formula ISH is given by VT by RSH. So on substituting the values, we get 3 amps. So IL is known and ISH is known. Therefore, IA is given by IL plus ISH. So that is 103 amps. So once you know these values, so you can calculate the EMF generated. Once you get the EMF value, you can calculate PA, that is E into IA. Therefore, E is given by VT plus IA into RA. So on substituting the numericals, we get 305.15. Next, the power developed by the armature is given by P equals E into IA. So E is 305.15 and IA is calculated 103. So you get total 31.430 kilowatts. Next one, so it is somewhat different. So a DC series generator. So here he has given series generator which has armature resistance of 0.5 ohm and series field resistance of 0.03 ohm. RA and RAC is given. it drives a load of 50 amps and IL is given. If it has 6 turns per coil and the total coils is 550 on the armature and it is driven at speed of 1500 rpm. Calculate the terminal voltage, that is Vt, at the load, and assume number of poles 4 and it is lab connected and the flux per pole is 2 milliwebers and total brush drop is 2 volts. So first take the given values. RA is given 0.5, RSC is given 0.03 and voltage drop across brush is given, that is 2 volts, and speed is given 1500 rpm. So here, instead of giving the number of conductors, he has given in terms of an number of turns and the coils. So to calculate the number of conductors, when it is given in number of turns, the formula is Z equals 2 into number of turns. So to calculate the number of turns, we have to consider number of coils and how many turns are there for each coil. So he has given a total coils of 540 and with a turns of how much, that is 6 turns he has given. Therefore, if it is as 6 turns per coil and total coils is 540, so the total number of turns is given by 540 into 6. You'll get 3240 number of turns. So to calculate the conductor, the formula is Z equals 2 into number of turns. So on substituting the values, we get number of conductors, that is 6480. So once you know the number of conductors, we know the general formula for EMF equation, that is Z pi n divided by 60 into P by A. So as it is a lab connected, A is always equals to P. So substitute the values and remember the pi is given in milliwebers. So 2 into 10 raised to minus 3 webers. So on substituting all the numericals, they will get E equals to, sorry, I need to calculate terminal voltage. So he has given 324 EMF. So on substituting, we'll get Vt equals 295.5 watts. And remember here we need to consider even the voltage drop across an brushes. So 324 equals Vt plus 50 into 0.5 plus 0.03 plus 2. Vt equals 295.5. So here from this one we can calculate EMF. So on substituting all the values, we will get 324 volts. So once you know the EMF, you will get the terminal voltage. So as it is a series connected, we have to write the formula Vt plus Ia into Ra plus Rsc, because we need to consider the voltage drop across the series winding, and as it is Vb. If it is given, we have to consider. If the Vb is not given, so we can leave. And next one, so it is based on number of lamps. So a long shunt DC compound generator. So this is a long shunt DC compound generator. It is going to drive 20 lamps and all are connected in parallel. And terminal voltage he has given 540 volts and each lamp resistance is given, that is 500 ohm. And RSH is 25 ohm and RA is 0.06 ohm and RSC is 0.04 ohm. So calculate the armature current and the EMF generated. So as it is a long shunt DC compound generator, so the formula will be, so that is IA is always equals to ISH plus IL, and ISH is given by Vt divided by RSH, and total EMF is Vt plus voltage drop across an armature across an series winding plus Vb. So on using that formula, so first here he has given the one more point additional what he has given, the load is in terms of lamps. So all lamps are in parallel, so the voltage across them will remain same. So the terminal voltage will be same in all the lamps. The current drawn by each lamp is given by I equals Vt by the resistance of the lamp. So he has given the lamp resistance 500 ohm and the voltage across a lamp is 550. Therefore, the current of lamp is given by 550 divided by 500, that is 1.1 amps. So this will become the current of an each lamp. So how many lamps he has given? So that is 20 lamps. So such 20 lamps will get IL equals 20 into the current across an each lamp, that is 1.1. So the total line current will become 22 amps. So this is the line current, and ISH terminal voltage is given and RSH is given, that is 25. So VT divided by RSH will get 22 amps. So IL is known, 22 amps, IS is known. So you can calculate IA equals IL plus ISH, that is 44 amps. So on knowing all the values, the EMF is given by VT plus IA into RA plus IA into RSC. As he has not given the VB value, so we can leave that. So on substituting all the values, we'll get total EMF is 554.4 volts. So this is all about the numerical examples on uh, generators. So that is based on EMF equation and even based on different types of generator. So you go with all these examples. So if you have any doubts with these numerical examples, you can contact me. So thank you.